All right, in this lab we're going to do moles of wax, and what we're using are small little tea light candles. I basically removed it out of the little metal tray that it often comes with. One of the things we need to consider, and we're kind of going to ignore it, is there is a little piece of metal at the bottom, and we also have a piece of the string, the actual material that's actually going to be the wick, I guess we're going to really call it, and we need to consider that there's mass there, but for the sake of the activity, we're going to kind of ignore that. And so what we need to do, we always want to tare our scale, and I'm in an area, you may hear the vents behind me. There's some motion going around from the internal room, and so when you have a current, a lot of times you have scales that are a little sensitive, so the numbers might fluctuate. We always want to hit the tares in 0 button before we begin. And so we're going to take our original reading, and all you have to do is take a look at that. So we have almost 10 grams, but make sure you do the actual recording. And so when you're looking at your data, we're starting at 9.98 grams, and what we're going to do is we're going to burn this for about 5 minutes. And so as we go through, I have a clock running here. I'm going to actually do it, and the goal is for 5 minutes, and we want to calculate a series of things that are dealing with stoichiometry and methochemistry, but we really want to deal with how much wax that we burn in 5 minutes. And so I'm going to light a match here off the screen, and what I want you to do as we're doing this is I want you to make some observations. And so right now, make a couple observations of what you see happening in the beginning, if anything. And again, you have your initial data. And what we're going to do, we're just going to sit here and watch. And so we may see some things, and I'm going to try to zoom in just a little bit, but we don't want to go off the mass. But we see that the mass has changed already. And unfortunately, the angle might be a little bit poor to see what's going on there, but usually if you think about a candle melting, you will see some of the wax. And let me see if I can zoom in on this just a little bit, just so you can see that a little better, maybe from a different angle. That the light is not very helpful because it's kind of reflecting. But we do see that we have our solid candle and we have a little of the wax. Now, the way a candle works, of course, is low melting points, and that low melting point has the ability to cause that solid wax candle to become liquid wax or melted wax. And we have a change there. Now, it's still wax. If you think about that wax, if we were to pour it off, it would harden. Maybe sometimes you've had a candle that had a little wax, or that poured a little bit, or maybe you try to blow a candle out, and next thing you know, the wax was all over the place. And so we have this idea that there's a change that's occurring. The question is that a physical change or a chemical change? And so we have to remember, if I have the same thing at the end that I started with, it's a physical change. So if I were to pour that liquid off, which I'm not going to do, we don't want to do that to the scale, but if I were to pour that liquid off, it would solidify again. It would turn solid again. And so that's a physical change when we're thinking about that with the candle wax. Now, if we're dealing with what's going on with the actual liquid wax, that liquid wax makes its way up through capillary action up through the wick, and that's a very flammable material. And so, if you just had a regular wick or a dry piece of material, sometimes you see candles that have sticks in them, and other looks like little rope in them. And what we need to consider, if you were to burn those without the actual liquid, they would kind of burn up and just get very ashy very quick. But these wicks will stay a very long time. Now, again, make some observations of what you notice on maybe the wick, maybe what you notice in the actual candle, what you've noticed already with the mass. We're at about 3 minutes right now. We're just going to estimate. I'm just going off the timer off of my phone as I record this. But again, we've already seen the mass drop, And it should be a pretty consistent drop. Now the question is, why is it losing mass? I still see the wax there, but where does it go? And so part of the lab is going to be a balanced reaction of the formula for wax and what happens during a typical combustion. Now this is an example of a combustion reaction. And during a combustion reaction, of course, we know that in order to burn things, we have to have oxygen present. And so oxygen is going to be one of those materials in the formula that you'll see in the lab. And with the presence of oxygen, of course, we're able to burn, and we have carbon dioxide and water that's given off as a byproduct. And so when we look at that, we want to make sure we have a balanced equation. Now, we're not going to have a whole mole of wax, so part of this activity is you're going to calculate what the molar mass, or the gram formula mass of the typical wax formula is. And so we're going to not even come close to melting a whole mole of it, but we're going to be able to measure a viable amount. And we can already see that we've dropped, again, a nice measurable amount because the mass is disappearing in theory. Now, the question is, where did those materials go? Okay, where did that extra mass go to? So, when you go through your questions and your analysis and even your observations, you're going to want to discuss those things. And so we're getting close. We got about another 30 seconds, and I'll give it to about, we'll do about 10 more seconds, 15 more seconds, and then that's again about 5 minutes. Now, it doesn't matter specifically how long we did it. We're just giving an arbitrary number just because we don't want to spend all day doing the lab and watching me. And so what I'm going to do is I'm going to blow this out now carefully. And again, try to make some observations. I'll zoom in just a little bit here. We can make a couple more observations, and we'll get back in just a second. We'll get you a little closer to see if you can make any observations on what you see and what's going on there. Now, as we continue to do this, and I'll pull back so we can see the actual mass here at the final end, what our final end point is for your final recording. But we again had things that were physical changes, and we had things that were chemical changes, or physical reactions and chemical reactions. So the question is, where do things go? Can I get them back? Under what situations might be able to recover it, or is it not able to be recovered? And so if you've ever had a candle at home, if you notice already, maybe one of your observations is, there's a decrease or like an indent in this. And so part of that is, when you originally get the candle's flat and whole. So where does that really go? So make sure when you're doing the lab, take a look, consider, what has actually been observed and, what you physically saw. And if we go back and scroll out, let me zoom back out here. And what we have, for some reason I can't zoom for a second. There we go. And we will go in and we'll zoom in on our final mass. And our final mass looks like 9.7, 9.71, okay, 7071. You can choose either one of those numbers. Notice how it went to 2. Like I said, I'm in an area where there's a vent, and unfortunately, some of the equipment is very sensitive, and so slight motion causes that to change. So be sure to answer all your questions to the best of your ability. Do not leave anything blank, and always remember that IDKs are not real answers, and they're not acceptable.